Good morning, everyone. Good morning. Hope all is well. Hope everyone's doing all right. Hope you had a great weekend. Everything's good. Trying to wait for everybody to get in here. All right. So, if I'm not mistaken, last class we closed out with 3-4. So we're looking to do 3-5 today. And that'll probably be all that we do, just 3-5 today. Before we get started, any questions, concerns, or comments before we go ahead and get into it?
You did say for section 3.2, skip that homework.
Yeah, yep. For right now, we're gonna do that. I'll make a final decision on going back to that or not, when we close out chapter 3, before we close out chapter 3.
Okay, thank you.
Yep, not a problem. Thank you for asking. All right, so 3.5 is rational functions and their graphs. So as before, when I mentioned graphs up to this point, you graphing by hand is not anything we're emphasizing at this point. So make sure you have a legitimate way of graphing your functions. So, a graphing tool, whether it's one that you, a calculator or something like Desmos, which is online, all you do is Google graphing tools. Use that to validate your graph if MATLAB asks you anyway. So first place we're going to start is asymptote, what we call asymptote. There's places where the function is undefined or does not exist. And there are also places where the graph does not cross. So I think I got some examples right here. Well, anyway, the graph would actually curve down and you'll have this invisible line where the graph would never cross. So we're going to figure out where these asymptotes are. So we have 3 types of asymptotes. We have a vertical asymptote, horizontal asymptote, and a slant, or sometimes called an oblique asymptote. Just depends on what your book have, what book you have, whether they call it a slant or an oblique asymptote, but they're the same thing. All right, the first type of asymptote is a vertical asymptote. Well, the first one we'll discuss is a vertical asymptote, and that is where the denominator is equal to 0. Is everybody doing the blue? All right, so there goes your 2 steps to solving your vertical asymptotes. First thing you want to do is simplify your expression as much as possible. Then say your denominator equal to 0 and solve. course, if I scroll up too far, let me know. So remember what we're doing, looking at this first, we'll find the vertical asymptotes, if any. We're going to simplify our expression as much as possible. And then we're going to set the denominator equal to 0 and solve. So this first one, we have f of x is equal to x over x squared minus 9. So there's nothing really to simplify here. It's just x over x squared minus 9. So we're going to take the denominator, set it equal to 0. Factor that out. We have x plus 3x minus 3. Solve both of them. We have x equal to -3 and x equal to +3. So we have two vertical asymptotes. So right here is just a rough sketch of what would happen in this type of situation. Our vertical asymptote would be right here and right here at 3 and -3. So it'll just be rough sketching what it would look like. But notice the graph wouldn't cross this line and wouldn't cross this line. All right, can we scroll up? All right, let me erase some of this stuff. All right, the next one is x plus 3 over x squared minus 9. So if you notice right here, I went ahead and factored out that denominator just like before, but we had something that can cancel out in the top with what was common with what was common in the bottom. So the x plus 3 that's in the top cancels out with x plus 3 on the bottom, and that leaves us with 1 over x minus 3. And so I try to color code what's going on here. You can't ignore that there was an x plus 3 in the numerator initially. And so that's going to produce a restricted value. So we still have to give an account for it, but it does not produce a vertical asymptote. So notice here what is left in our denominator, x minus 3, that will produce a vertical asymptote, but we still have a restricted value from the other piece that canceled out. So when you simplify, whatever stays is going to be your vertical asymptote, but whatever canceled out would be a restricted value. It's like in other words, remember we had graphs before in the past and there was an open circle there. So that will give you an open circle. Matter of fact, I'll probably stay green since we're color coding. All right, so go ahead and set both of them equal to 0 and solve just like before. It's just that once again, that x plus 3 that canceled out produces a restricted value, and the other one, x minus 3, produces a vertical asymptote.
So if the problem's just asking for a vertical asymptote, we would leave out the restricted value.
Exactly. All right, gonna scroll up. All right, the next one, we have h of x is equal to x plus 3 over x squared plus 9. So do the same thing. Want to look at your denominator, see what you can do with it. We have x squared plus 9. Remember before we had x squared minus 9, so we can factor x squared minus 9. X squared plus 9 cannot be factored. So we'll go ahead and solve, set it to 0 and solve for x. That's what we're doing right here. Notice we end up getting an imaginary number. So that means that there are no vertical asymptotes. All right, can you scroll up? All right. Don't copy this stuff in the middle. We're just going to the horizontal asymptote. All right, so looking at horizontal asymptote, first we're going to let n represent the degree of the numerator, let m represent the degree of the denominator. Don't forget degree means highest exponent. That's what I wrote right here in the red, highest exponent. So the highest exponent in your numerator is the degree of your numerator. Highest exponent in your denominator is the degree of your denominator. So if the highest exponent in your numerator is less than the highest exponent in your denominator, y is going to be equal to 0. Also, notice we're looking at y equals now. But when we were doing our vertical asymptote, we had x equals. You see x equals. So vertical asymptotes, x equal, horizontal asymptote, y equal. So make sure you take note of that. All right. Now, if your numerator is is equal to your denominator, then you're just going to take the leading coefficient of the numerator, place it over the leading coefficient of the denominator. Simplify that, and that would be your horizontal asymptote. Once again, notice y equals. Then for the last situation, if n is greater than m, in other words, your numerator's exponent is greater than your denominator's exponent, there is no horizontal asymptote. That actually will take us into a slant asymptote. And we'll talk about that as our third scenario. All right. Any problems before we try it out? All right, so find the horizontal asymptote. If there is one. So we have f of x over 2x squared plus 1. So of course that one wouldn't be there. I was just notating that if you don't see anything, then assume there's a 1 there. So the highest exponent in our numerator is 1. Highest exponent in our denominator is 2. So that gives us the first scenario of n is less than m. And so no calculation needed. If your numerator's exponent is less than your denominator's exponent, your horizontal asymptote is 0. All right, any problems? All right, the next one, we have 4x squared over 2x squared plus 1. Our exponents are the same. So if your exponents are the same and you take the coefficient, that's the number sitting in front of your variable of each one. That'll be 4 over 2. And simplify if possible. So y is equal to 2. All right, questions, any questions? Then the last one for your horizontal asymptote, 4x cubed over 2x squared plus 1. So our numerator is greater than our denominator's exponent or degree. So since that's the case, there's no horizontal asymptote. Any questions, any questions? All right, last one. So your slant asymptote, when n is greater than m, your numerator is greater than your denominator exponent, there should be a slant asymptote. And so we would use long division or synthetic division if possible to find it. All right. So it's going to be the form of y equal to quotient plus the remainder. So, when we do our long division, you'll have your answer part that comes from the division. Then you have your remainder. So that first part, that part that is considered your answer before you get to the remainder, is your slant asymptote. And then once again, we're going to do y equals. that third scenario, we didn't have a horizontal asymptote. That's because a slant asymptote takes on that position. So it's going to be y equals. All right, scrolling up. All right, so notice we have x squared minus 4x minus 5 over x minus 3. So greatest exponent, or not, yeah, highest exponent in our numerator is 2. Highest exponent in our denominator is 1. So that means our numerator is greater than our denominator as far as our exponents are concerned. So we can go ahead and use synthetic division in this case, because we have this x minus 3 situation. So if that's the case, if it's x minus 3, that means we use the opposite here. So that's why we have positive 3. Then we use all of our coefficients. That would be 1, -4, and -5. You go through the synthetic process, bring down your 1. 3 times 1 will give you 3. -4 plus 3 is -1. 3 times -1 is -3. Add those together, and that'll give you -8. So -8 is our remainder. And so that'll give us x minus 1 plus -8 over x minus 3. And so that first part, that is not the remainder, the actual answer part, that's called your quotient. That's going to be your horizontal asymptote, your slant asymptote. So notice with the problems that you guys get, you will not have a horizontal and a slant. You will have a horizontal or a slant. So you won't have the both at the same time. So you will have vertical asymptotes. So you can have a vertical asymptote and a horizontal asymptote, or a vertical asymptote and a slant asymptote. You just can't have a horizontal and a slant with the problems that you guys will have.
So how will we tell when they want the answer that includes the remainder or the answer that doesn't include the remainder? Will that they specify that?
Well, that's the only time you include the remainder is if you actually want that divide. If they say divide and they want to answer, so that wouldn't be this section. This section is just asking for the asymptote.
Okay, thank you.
So that first section that we did, you would give this whole answer. But in this section, all you would give is x minus 1. Good question, good question. Anything else before we do another one? All right. So the next one, x squared plus 1 over x minus 1. Once again, we have squared over just a linear x to the first power. So we could do not synthetic. So we have to do division because we have a slant asymptote. Now in this case, we still could do synthetic division. And we have a missing term here. So always make sure you're cognizant of your missing terms. X squared plus 1. We have our x term that's skipped. So we have to give an account for that. So that's why my coefficients here, I have 1, 0, 1. All right. And then of course, because of this, we use the opposite. So we have just a 1 here in the box instead of -1. So first move, bring down the 1 that we have. 1 times 1 is 1. Add that to 0, that's 1. 1 times 1 is still 1. Add that to 1, and that'll give you 2 for a remainder. This time our slant asymptote will be y equal to x plus 1. Questions? Any questions? Everybody good with the process? I think that was my, yeah, it's my last one. Everybody good with the process of all 3? Any questions on either one of the 3? All right, before we close out today, any questions? Remember today I'm gonna do 1 section. That's all that section pretty much holds for us. Anybody have any questions on anything else? Anybody try anything, get stuck on anything? Got time if you got it. So everybody's good, everybody's straight at this point. Make sure. Just closing out class early today, because I try to keep my classes on pace with the same content, unless, y'all questions, pushes back. I don't have a problem with that, but as far as lecture is concerned. And so my next class, I do have to cut short because of an appointment, dental appointment. So I was just, there was no rush, but I have to do 2 sections today. So unless y'all really want us another section,
I think I'm fine with the 1 section.
Yeah.
All right, sounds good, sounds good. So everybody good before we close? I just want to make sure.
Thank you.
Okay, not a problem. Thank you, thank you. All right, so you guys have a good one. Be safe. Wednesday, we'll pick up here with our next section. Go from there. Y'all take
Thank you,
care.
Professor. Have a good one.
Thanks,
Thank
you the
you.
same.
Thank
you.
you.
Have
Have
a
a good day.
Thanks, do the same. Thank you, take care.